Welcome to Section 3, Applications in Unsupervised Learning. In this section, we're going to talk about unsupervised learning. And specifically, we're going to cover k-means clustering, and we're going to use k-means clustering to do clustering of patients with diabetes. And we're going to talk about dimensionality reduction with PCA, and we're going to use PCA to compress images. Intro to unsupervised learning. In this video, we're going to talk about what unsupervised learning is, why it's important, and we'll cover briefly what the two types of unsupervised learning that we'll be covering, clustering and feature learning. So previously, in our setup of supervised learning, we had an X and a Y. We had our data inputs and we had our Y outputs, and these were our labels. This can be for regression tasks, for classification tasks, but we were given a Y and we were given this task of learning a mapping from X to Y. In unsupervised learning, we are given X, but we are not given Y. And the purpose of unsupervised learning is to find intrinsic structures in the data without relying on any labels. So unsupervised learning is important because the vast majority of data is actually unlabeled. The data that is around us, what we take in as inputs, most of it is not cleanly labeled like a lot of the data sets that we've been working with here. And it's important that we're able to learn without labels. Humans are capable of doing this. We don't have an explicit label for everything we're taught. So this seems to be a core part of intelligence and something that we want as part of our machine learning systems. A powerful and common type of unsupervised learning is called clustering. And in clustering, you're given X the data, and we want to map to a certain amount of clusters. And these clusters are almost like the labels that we discover. The data is not labeled, but if you were to look at this, you could see, oh, maybe there's like three groups here. There's this top left group, there's this middle group, and there's this bottom right group. And you might classify those into clusters, something along the lines of this. And we can do this because we can see these patterns, and k-means clustering allows you to do this sort of task without being given explicit labels. There's also unsupervised learning in feature learning. So a task like compression, can you take an image, reduce it down to a smaller size, and then recreate that same image? So in the reconstruction part, you are learning about the input in a more compact form. And that means that you are learning features that are not the exact input, but that are important to represent the input in its full amount. So what we'll be doing later in the section is taking an image that may be 12 megabytes, compressing it down to something that's 2 megabytes, and then reconstructing the original image as best we can. And the goal here is to reduce the original image down to just its core essentials, so that with the core essentials we can reproduce the original image. And if you learn those core essentials, you've learned something, some intrinsic structure about the data.